Hello everyone. In this video, we are going to see the counterbalancing circuit on a hydraulic system. That is, how the counterbalance circuit is working. Mainly, the counterbalancing valve is used in this circuit to hold the load, that is, overhanging load, for a long time without moving due to gravity. Some cases, if it is a load, overhanging load is high, then due to gravity, there is a possibility of moving the cylinder without operating the circuit. To avoid such instance, we are going to arrest that particular movement with this counterbalancing valve. Now we will see the working principle of counterbalancing circuit, and also we will do the simulation using this AtomSim software by the AtomSim software for this particular circuit. Okay. See, for this circuit, we need a component, one power pack, one pressure relief valve, one 4x3 directional control valve, one pressure relief valve, and a check valve. Also, we call this as counterbalancing valve or braking valve, and one double acting cylinder. This particular double acting cylinder is mainly used for overhanging load. Then only this counterbalancing valve or counterbalancing circuit is used. If it is in horizontal position, there is no necessity of utilizing this counterbalancing valve. So mainly counterbalancing valve is used for the cylinders which is mounted vertically for lifting the loads. Now we will see the working principle. Here in power pack, we have a reservoir, filter, and a hydraulic pump with motor. Then there is a pressure relief valve, which is used to release the excess pressure developed in the circuit. And you have a 4x3 DCV, that is 4 port or 4-way 3-position directional control valve. And the exit of this DCV, one port is connected to the exit of the cylinder and another port is connected to the entry of the cylinder. In exit port of that cylinder connected with the counterbalancing valve. While operating this hydraulic pump, hydraulic fluid is supplied to the DCV. There are 3 positions. First one is ideal position, second one is straight position, third position is cross position. In ideal position, fluid is directly go to the reservoir. If you are engaging the directional control valve in first position, then fluid is flowing either lifting or lowering the load. During lifting, there is a counterbalancing valve. So in this, you have a pressure relief valve and a check valve. For lifting the load, fluid is flowing through this port and entering to the pressure relief valve. Also entering through this check valve also. So more fluid is flowing through this way and lift the load. During lowering the load, by changing this directional control valve in cross position, fluid is flowing through this way and push the piston down so that weight is weight due to self weight of that load attached in this piston rod, also it will come fast. And here you have a check valve, sorry, that is a counterbalancing valve, which minimize the fluid flow. Also, check valve will not allow the fluid to go through this bypass. So only the allowed pressure of fluid only passing through this counterbalancing valve. Once you stopped this DCV, then that position itself, the ram, that is piston rod, is holding for a long time until the further pressure developed in the circuit, the piston is not moving. This is the working of counterbalancing circuit. Let me see the simulation of counterbalancing circuit by using AutomSim software. Okay. First, open this AutomSim software. See, here there is a hydraulic actuators. To construct this counterbalancing circuit, we need one double acting cylinder that is in vertical position. So double click it, rotate this cylinder in 90-degree, select it and drag it. You can customize this cylinder by means of double clicking this. We can change the rod either double acting or single acting. By means of clicking this, you can change the piston type also. By means of clicking this tab, you can change the rod, end rod, like this. This is the load attached in the cylinder. For constructing the counterbalancing circuit, we need a 4x3 directional control valve. So 4-way 3 position control valve and one pump, 2 reservoir symbol. One is attached with DCV and one is attached with pump. We can directly connect this here also. By simplifying the circuit, I attach this symbol here itself on water and on filter, on pressure relief valve, on inlet pressure monitoring unit, pressure gauge. I can modify this as a filter. Attach with this, then attach the reservoir here. After that, I will connect this pump with the directional control valve. I will connect this pressure regulator with this pump inlet, outlet. Connect the pressure gauge with this circuit. Now we have to introduce one check valve and one pilot operated pressure relief valve. First, choose any type of pressure relief valve. By means of double clicking it, we can customize the pressure relief valve. I will choose pilot operated valve, that is counterbalancing valve, from this list. Okay. Now we will make the connection. So set the in position. connect these two, and this also. The pilot line is connected in the entry, and this will be connected to the exit of the double acting cylinder, and the entry of the cylinder is connected to the DCV, and this point is connected to the counterbalancing valve. And we need to customize this DCV by double clicking this. I will choose push button operated DCV. If you want to change the positions, you can change. Cross position is left side actually. If you want to cross position on right side, you can change by using the tab cross position. Okay. So this is the simplest construction of a counterbalancing circuit. Here we need to check the pressure of this pressure relief valve as well as this counterbalancing valve. So initial pressure is 10 bar. I will set that as 10 bar. The pump pressure is in 10 bar. If pump pressure 10 bar, up to 6 bar pressure only, it will extend the load. So this also we need to check. This also 6 bar. I'll set this 11 bar. Okay. Now we will check the simulation. See, initially it's in ideal position, so fluid will not flow in this circuit. Up to DCV, then it will come back to reservoir. So 10 bar pressure is there. If pressure increases, then pressure relief valve will open, then excess pressure oil will be come back to reservoir. I change this position by means of pressing this push button. It's moving, right? Now what happened? Fluid is flowing through this way and fill this cylinder so that increasing pressure inside the cylinder, piston is moving down. The return line is blue line. The fluid is coming back through this circuit and fluid will flow through this check valve. Sorry, it is in opposite direction. Okay. Through this position, through this counterbalancing valve and come back to reservoir. Now I will change the position, cross position. See, fluid is not flowing. Fluid is not flowing because of this check valve. I will change this position now. Now, right? It's moving because during supply of forward stroke, fluid is flowing inside. The excess pressure developed inside this cylinder. That means in this side you have hydraulic fluid. That fluid is coming out this way. Up to 10 bar pressure, this will open. This check valve will not allow the fluid to go back to the reservoir through this way. So all fluid will come back to this. So that due to self weight, there is a pressure increases. So this pilot circuit is open the spring for that means counterbalancing valve and fluid is flowing through this passage and to reservoir. right? And return stroke, fluid is flowing through this check valve. That time this pressure relief valve will not operated. That means opened, not opened. Check. So it's open. Now it's not working because of the pressure difference. Okay, by this way, we can do simulation of counterbalancing valve. If you change this position, stop this. Now it's working. Let me see. Right. I will change this pilot line this side so that you can monitor, you can see the difference. Stop this. Because of understanding purpose, I modify these component. Okay. I will. Okay. Now I will connect this pilot line this side. Let me see how it's working. Because now we will see. Forward stroke attained, then return line. So there is a pressure drop. There is a connectivity. Right? Now it's working. Due to the pressure, check the pressure now. It's 6 bar only. So I will set that as a 10 bar. Now it's working. Okay. So by this way, we can do simulation of counterbalancing valve. Mainly it is used to overhanging load, to lift the overhanging load, to withhold the load for particular position. Thank you.